Imagine waking up one morning to a sky that looks different. A sky altered by human hands, engineered to shield the Earth from the sun's relentless heat. A bold, controversial idea called solar geoengineering could block part of the sun's energy from reaching the Earth. By injecting aerosols into the atmosphere, brightening clouds, or even placing mirrors in space, researchers say we might slow global warming. Turns out we wouldn't need to block out much of the sun. Just 1% less sunlight could be enough to cool the planet. But at what cost? This idea comes with huge risks. Changing the atmosphere could disrupt weather patterns, cause droughts, and create international conflicts. Some experts warn that if these projects stop suddenly, global temperatures could spike in a dangerous termination shock. Still, small-scale tests are underway, with some scientists arguing we may have no other choice. But what exactly is solar geoengineering, and why is it so controversial? The planet is heating up at an alarming rate. Global temperatures have surged dramatically due to greenhouse gas emissions, leading to extreme weather events, rising sea levels, and devastating heat waves. Despite global agreements aimed at cutting emissions, we're still far from reversing the trend. So what happens when the Earth gets hotter, faster than we can cope with? Experts warn that we are approaching critical tipping points, the moments when climate shifts become irreversible. Imagine the collapse of polar ice sheets, the shutdown of ocean currents, or the loss of vital ecosystems like the Amazon. These changes could trigger a cascade of uncontrollable consequences. The UN's Emissions Gap Report recently revealed that even under the most optimistic scenarios, there's only a 14% chance of keeping global warming below 1.5 degrees Celsius, the threshold set by the Paris Agreement. So with the stakes so high, what options do we have left? Enter solar geoengineering. Also known as solar radiation modification, SRM, this strategy involves large-scale interventions designed to cool the planet by increasing the amount of sunlight reflected back into space. Unlike traditional approaches like cutting emissions or removing carbon dioxide, SRM doesn't tackle the root cause of climate change. Instead, it offers a temporary shield, attempting to reverse some of the warming effects by altering the flow of solar energy to Earth's surface. But could this be the solution? Or is it just kicking the can down the road? Some scientists view solar geoengineering as a last resort strategy. If emissions rise unchecked and climate disasters worsen, SRM could buy time for sustainable solutions. However, the risks are enormous. The Earth's climate is interconnected, and tampering with it could lead to unpredictable consequences. For decades, altering the climate was seen as radical and dangerous. But as the climate crisis accelerates, some researchers and policymakers now take it seriously. While the UN's IPCC acknowledges SRM's potential, they warn of its dangers. The debate is contentious, with critics fearing geopolitical conflict and disruptions, while others see SRM as a necessary high-risk solution. So how does solar geoengineering actually work, and what methods are scientists proposing? One of the most researched methods is stratospheric aerosol injection, SAI. What if we could dim the sun? Just a little. That's the idea behind stratospheric aerosol injection, SAI, a technique inspired by nature itself. When massive volcanic eruptions occur, they release clouds of sulfur dioxide into the stratosphere, forming reflective particles that temporarily cool the planet. The 1991 eruption of Mount Pinatubo, for example, lowered global temperatures by about 0.5 degrees Celsius. So, could we recreate this effect on purpose? Scientists think so. But in reality, executing this on a large scale could be an enormous challenge. Fleets of high-altitude aircraft or specially designed balloons would need to continuously release these particles, as they naturally fall out of the stratosphere over time. And the cost? Estimates suggest keeping this system running could require billions of dollars per year. Even if the funding were secured, SAI comes with serious risks. What if shifting global temperatures altered rainfall patterns, causing droughts in some regions and floods in others? Could it damage the ozone layer, exposing us to more harmful UV radiation? The potential consequences make SAI one of the most controversial geoengineering proposals out there. Too extreme? What if we brightened clouds instead? Marine cloud brightening, MCB, is another idea that could help cool the planet. But instead of blocking sunlight from above, it enhances the reflectivity of clouds over the ocean. The concept is surprisingly straightforward. Spray tiny seawater droplets into the air, increasing the number of small cloud particles. These smaller droplets reflect more sunlight, reducing the amount of heat reaching the Earth's surface. We've already seen this effect in action. Ever noticed how pollution from ships can make clouds appear whiter and denser? That's a real-world example of MCB in play. While MCB could be used on a regional scale, such as to protect coral reefs from heat stress, studies have raised concerns. A recent experiment off the US West Coast suggested that modifying clouds in one area could disrupt ocean currents and worsen heat waves elsewhere. The long-term effects of such interventions remain uncertain. Another bold idea involves placing mirrors or dust particles in space to block a fraction of sunlight before it reaches the Earth. One of the most ambitious proposals suggests positioning a giant sunshade at Lagrange point L1, a stable spot between the Earth and the Sun. In theory, this could lower global temperatures, but in practice, the challenges are staggering. First, there's the cost. Launching and maintaining such a system would require an investment in the trillions of dollars. Then there's the sheer scale of engineering needed to construct and position a structure large enough to make a difference. Even if we could overcome these hurdles, space debris poses another major risk. A single collision could destabilize the entire system, making this solution as risky as it is ambitious. While solar geoengineering might provide a temporary cooling effect, it comes with a host of risks, unintended consequences, and ethical concerns. What if solving one problem creates another? Geoengineering could disrupt global weather patterns in ways we can't fully predict. Injecting aerosols into the stratosphere might cool the planet, but could also reduce rainfall in some regions, causing droughts or intensified storms. Marine cloud brightening on a large scale could interfere with ocean currents, worsening conditions in certain areas. Another major risk is what happens if we stop. If a large-scale project like stratospheric aerosol injection is halted, temperatures could skyrocket as trapped greenhouse gases take over. This termination shock could trigger extreme weather, ecosystem collapse, and a climate catastrophe even worse than before. There's also the moral hazard argument. Critics warn geoengineering could be an excuse to delay real climate action, masking the problem while industries keep burning fossil fuels. Geopolitical tensions are another concern. If one country deploys geoengineering, others might oppose it, facing negative side effects. This could spark conflicts with no formal international agreement on governance, leaving the door open for unilateral action by a powerful country or private entity. For these reasons, many scientists see geoengineering as too risky, but others argue it could be a valuable tool with proper governance. But where do these ideas stand today? Has anyone tested them? Despite the controversy, small-scale experiments and studies are already underway. Harvard University's Solar Geoengineering Research Program has been studying stratospheric aerosol injection, though a proposed outdoor test was recently cancelled due to public opposition. In Australia, researchers have conducted marine cloud brightening experiments to protect the Great Barrier Reef, but results are still inconclusive. Meanwhile, some private companies have already taken independent action, releasing small amounts of aerosols into the atmosphere and selling cooling credits without government approval. Many scientists and environmentalists have condemned these unregulated efforts, warning that they could lead to unintended consequences and undermine serious scientific research. International organizations like the United Nations, UN, and the Intergovernmental Panel on Climate Change, IPCC, acknowledge that solar geoengineering is an area of active research. But they warn against its risks. While large-scale deployment remains uncertain, the increasing urgency of climate change might push governments to consider these controversial methods in coming decades. Solar geoengineering presents a potential emergency tool for cooling the Earth, but it comes with massive uncertainties. While the science behind it is advancing, the risks of unintended consequences, geopolitical conflicts, and long-term dependence make it a high-stakes bet. So, is this the future of climate solutions, or the start of something we can't control? Should we even be considering geoengineering, or is it a distraction from the real fight? Let me know what you think in the comments. If you love deep dives into the biggest, most ambitious projects on Earth, consider joining us on Patreon. You'll get exclusive content, early access to videos, and help us keep making these in-depth explorations. Check it out below.